Stream is live. Cool. Well, welcome back. It seems that not only am I good at amp repairs, but I am also good at promising everybody I'm going to come back and then I disappear for like a couple weeks. But I'm back. We're going to get part 2 of this SUNFIRE amp done tonight and hopefully get it tested out and working. And I'm not going to make any promises that I'm going to do anything else. We'll just see if we can get this one done and see what happens. Part of the delay was actually waiting for parts. COVID has severely disrupted the supply chain, and it's just kind of hard to get parts now. A lot of the big manufacturers need some of these things, and their orders take priority over mine, so it is what it is. I mean, everybody's used to waiting for pretty much everything these days, so I'm sure, you know, somebody that has a broken subwoofer isn't going to be too upset if they have to wait a couple more weeks to get it back. So let's get into this. We kind of left off with this guy here, and as you can see, you know, the bench has remained intact while I was away, but I do have the replacement caps. Hopefully I have all of them. I believe I do, but we're going to start off with these 47 microfarad 200 volt jobs that replace these REC. I don't know what REC is. Really efficient crap. That's what that stands for. Alright. But yeah, let's get back into the swing of things and let's get this amp going. I'm not going to waste any time today because it's already kind of late. And I want to get this thing up and running. I did have some fun while I was away though. I've been working on getting back into flying drones. I like to 3D print them and the real small micro stuff, so I've been playing around with that and having some fun. It's good to take some breaks and have some fun. Can't be all work all the time, and my regular job's been kicking my ass, so it's like I had a little vacation. I'll take it. But we're going to get right into this tonight. We're going to get this bad boy up and running. I had my first repaired defeat this week. I was working on one of the micro drones, and I'm using a cheap Happy Model 1 cell flight controller. Real small thing. I'm actually running it on an 18650 battery. I might do a video on it just as one of my hobby videos. But the board uses 0204 size components, and those are too small for me to solder, even with a microscope. Like, I mean, I have a pretty good set of tweezers. I mean, these guys go down almost to a needle point, and I cannot hold the parts with them. Like, they flip around, they're too big, they get in the way, and I don't have a soldering tip that's small enough to do that either, so I admitted defeat. Luckily, the vendor was super cool, and they sent me a replacement, even though it was my fault for breaking it. So that was nice of them. And I've actually broken 2 of those. The other one was just being stupid. When you hook the minus of a battery up to the plus terminal and the plus to the minus, and then you try to power things on, sometimes it gets a little angry. I don't think anybody that's built a drone has not been through that. But anyways, yeah, I've been having some fun playing with my toys. But now we are going to get back into fixing some amps. My pile has not grown any smaller, that's for sure. Alright. So we got the I don't like the way that one's in there. It's got to go in a little bit more. We got the high voltage filter caps in, and these are usually a problem. Anyways, they wear out, they dry out, and they are a source for hum and noise. So if you're getting hum in your SUNFIRE amp, you always want to replace your big filter caps that are by your supplies there. These are your your two rails, your positive and negative rail. I believe they're like 160 volts. But these two caps are a source of noise, and it's kind of weird because they all use the same schematics, but they're kind of laid out differently. So this is a HRS amp, so it has this like little daughter board in it, and it's kind of mounted funky. But almost all of them, like the MK2s and the Super Juniors, they all have like kind of the same topology and the same part layout. They're just kind of placed differently. But make sure that you check these guys and replace these guys because they are a source of problems. And I'm going to be drinking a ton of coffee tonight, so you guys are just going to have to deal with it. I didn't get my morning coffee this morning. I was too busy, which really, really sucks. But, alright, so let's see where we left off here. We got most of the caps replaced. I know we put some of them back in because I couldn't get the right sizes. And I'm just making sure I didn't leave anything out. It's hard to kind of pick up where you left off when you run out of parts. I'm usually pretty good at leaving placeholders in, but sometimes I get screwed up. So I did order, I think, all the caps that I need. We're gonna find out. So 220 at 16 volts. I know I got some of those. That's these guys here. And I'm going to make sure I did not already replace them. No, those are S.Y, whatever that is. And I'm going to replace those with Nichicon UV-Z series. I couldn't find the PS in the smaller package size. They're rated for a little bit less on time at temperature, but this isn't really a hot section of the board, so we can kind of get away with using those there. These are probably only 85C caps anyways. Oh no, they're still 105C, but either way, it's still an upgrade versus what's in there. So it will be fine. Especially, you know, I always put a little message in there when I return the amp, like, hey, you know, like when you're done watching TV or listening to music, just go to the back of your sub and turn the power switch off. It takes a second to do, and you will, you know, quadruple the life of the equipment if you just simply turn it off. And there's no reason why you need to leave things powered on 24/7. One, because it adds up in your electric bill and you're paying for it when you're sleeping. That's kind of crazy. And two, because you're going to end up paying for it again when you pay me to fix your amp. So take the couple minutes and flip your power switches off when you're not using this stuff, and it really does make a difference. Like the caps and everything just lasts longer. So I'm heating up the solder sucker here, and it's getting slower and slower. It seems the more as I use it, my heating element's wearing out. But looks like we have 3 left on here for this board, and then we can go on to the main board. I know I have these big monsters here. I got some good Nichicon replacements for these. I don't really know what to do with these caps. I should just save them all and throw them in a bucket and sell them on eBay or something for some kid that's like trying to do something as a hobby. I hate throwing them out. A lot of them are still good. Some of them are bad, but anybody has an idea of what I can do with my old caps, leave a comment in the comment section. Like, I don't know, I'm sure there's somebody that likes to tinker. Now, granted, these are garbage. You don't want to put them in anything that you own that's good, but for messing around with something or prototyping, I don't know, it might be good for something. I don't save them because I'd have no room left. I'd have all caps everywhere. Alright, so yeah, I did take this one out and soldered one leg back in. SY 105. Goodbye. Actually, I'm going to double check. Where are we at? 220 and 16. 220 and 16. Verify polarity. You'll know when you don't get the polarity right. It's when you have the amp all back together, it's in the worst possible place, and you turn it on and the top of the cap blows off. And then you have to take it all apart, clean up all the leaked electrolyte all over the place. Some of you might have saw that, and I cheated and bent that lead. I'm only bending it just to hold the cap in place so I can get the solder joint good and get, I'll push it from the bottom up against the board. It's too hard to work upside down and flip, and I'm trying to keep my head out of the videos so you guys can actually see what the heck I'm doing. But I bend those leads right back. Don't leave your leads bent. All of the eBay technicians cry when they work on stuff that has bent leads. Alright, where are we at here? C200. And it was kind of painful ordering these parts. Like, the prices of everything is just astronomical right now. I needed to order some Molex pins, and the pins are like $1 a piece now. It's brutal. Used to be able to get a bag of 500 of them for 20 bucks. Just everything's just painful. I got to do some work on my car tomorrow. I'm scared to go to the auto parts store. Brake caliper's probably $1,000 now. Steel shortage. Just hoping it ends soon. Everything's crazy. The housing market is crazy. I don't live in, like anywhere super fancy or special, but the houses by me, and they're not even really that nice, are selling for like 300 grand. I don't understand it. Like, what's gonna happen when the market goes freaking crazy and nobody has any money and nobody can pay? Yeah, I mean, it's gonna be a repeat of what happened before. Everybody's gonna be foreclosing on their houses. Absolutely nuts. Alright, I think this is the last one, and it's a 220/25, and it's a fat one. And I should have that. 220. I ordered a few different sizes. And you gotta bear with me because they're all in a box right now. My BBOP. Some of you will get that reference. I won't explain it. But it's actually my big box of parts. I didn't file these away yet in my little bins. Most of these are exclusive just to this amp that I'm working on, so I figure I'll just leave them in the box and then I'll reorganize all my little bins to house them. But yeah, so I mean, sure, this cap would fit on the board and work, but the diameters are slightly off, and this one's probably 8 and this is a 10. The original one had an 8 in it, so I'll put an 8 in it. And this is a UPS series, just different can size. I mean, if you're in a pinch and you're doing this for yourself, it really doesn't matter what you stuff in there. It could be a 500 volt one if you wanted it to. It'll still work, just not very practical. But depending on what parts are available to you and how OCD you are, it really doesn't matter. And we checked the polarity on that. And I'm just going to double check it because sometimes when I'm talking I make mistakes. Yes, the little plus sign is there. I hate when they put the polarity underneath the cap. Whoever does that on a board's an idiot. I like it when there's like a minus symbol or a dash or something that's clearly visible that says, hey, this is where this leg goes. This is how you do it. Because, I mean, I can look at the top of this board and I can have a ton of mistakes on there and I'd never know. There's no notches. There's nothing to mark the negative polarities on any of these. I disagree with that. So if you saw in the first part, we saved a bunch of time by kind of squeezing these in there without removing these boards, and I'm going to try and do that from now on. If any of you guys that have worked on one of these have done that, let me know how you do your boards in there. I used to remove all the glue off the bottom, then suck all of these pads, I guess, clean, and then you have to get in there with a razor blade to make sure you break it, otherwise you rip the traces off the board. It's kind of a nightmare. It's the one thing I don't like about working on these boards is the daughter boards, but being able to pull those out without taking the daughter boards out was kind of a game changer on these. And I mean, it's not really a speed contest. It doesn't matter, but it sure is nice to save some time and not risk extra damage to the board. So we'll get this guy trimmed up and set him aside. That one lead shot up. I'm sure it went into my coffee, because I have no clue where it went. Get our leads trimmed. And I'll clean these boards up later with some flux off. But for right now, we're just going to set it aside. Double check, make sure there's nothing missing that should be there. Sometimes you have to look at the bottom of the board too, because every once in a while you'll get a sneaky one from the factory that they didn't put in. While we're at it too, I know this guy's been waiting for a while. I finally found a board layout for this online. It took frickin' forever to find, but I have everything I need now to get this Infinity board back up and running. And I don't know, I think I posted that video on there, but this is the one that had the hole completely burned through the board, and we rebuilt the board, epoxied the hole in, got rid of all the shorts, and now we have to redo the copper layers on it. And generally, this is not something that I would do, but as I said in there, I'm doing it just because it's good content for somebody that really wants to put the time in to do it. Like the amount of time I'm going to spend working on this board, I could have bought the guy 2 of these brand new and still been ahead. So just something for, I guess, a future video. And it's going to require a lot of work. This thing, I mean, was totally destroyed. All of these surface mount components pretty much have to be replaced on here from this side of the board up. So not worth it, but I'm sure the guy that I'm doing it for will appreciate it. And I guess that kind of makes it worth it. Alright, here we go. Back to this guy. So this was one of the main sources for our noise, and this cap here that I saved was the problem. And we will zoom in here real quick, just so nobody has to rewind and look, but come on, camera, be nice to me. Zoom in, zoom in, zoom in. It's still kind of hard to see in the camera, but this cap is bulged on the top. It's not flat. I wish I could get a good reference. You really have to look at it. I guess you can kind of see it there. It's domed out on the top. It's not flat and it's not concave. And that's one of the things you have to look for when you're working on some of this audio equipment. Some of these things, it might not be leaking all over the board, but you definitely want to check the tops of the caps to see if they're domed out. If they're domed out, that usually means they've been heat stressed and they're on the verge of leaking. And they don't always leak from the top too. Sometimes they'll leak through this little rubber bottom of these things where the legs come through. Sometimes they'll leak and it'll burn the through hole or the pad out. So whenever you're working on anything that's older and needs to be serviced, you're better off just replacing all the caps, because if you just do the ones that are visible, you're probably going to miss a few that are having some issues. So keep that in mind. All right, the input board is done. We finished that in part 1. I don't know if the pots are scratchy yet. We might have to hit the pots with some deoxit. Now this is the board we don't remove, because I don't want to deal with any of that like weird silicone stuff, and this is the stuff that's not conductive, so it's actually pretty good. So I just leave that in there. Although there's a metal shaving in there, that is not going to stay in there. I don't know where that came from. Maybe from me. But either way, that can't stay. So alright, back to this guy. I like how they put the diode bridge like way off the board in one of the more precarious, I can't even say the word, in a weird place where something can just bend over and short into it. They should have put a little bit of fiberglass on there, at least to insulate the every other leg or something. I don't know. All right, 1000 microfarad, 25 volts. I know we have that. And I got the I believe these are UPS series. They're a little bit taller than the ones that were in there, but they'll still be probably around the same height or less than the bridge. So these are the UPW series, and I had to get these because I wanted the 105C rating and I wanted the same diameter. Still Nichicon. Surprisingly, I didn't use any Rubicons in these. Usually I do on those little daughter boards, but I went to a larger cap on this one this time. So out with the garbage and in with the good. This is an interesting board too. Ooh, that's not good. Alright, here. Let's show you guys this. This is a factory defect. Bob Carver would be pissed right now. I just noticed. Well, one, I noticed that this wire is extremely just flimsy and loose, and it's probably from vibrating around in there. But either way, that needs to be resoldered in. I'm gonna have to check everything on this board now. But I just noticed this filter cap on the. I guess this is like an EMI filter for compliance or whatever. But this leg of the cap is not even in the board. I can slide my little pick right underneath it. And I didn't do that. That is a factory defect. I'm glad I caught that and I was looking. Now I gotta see what else is screwed up on this thing. And everything else does look alright. Solder joints look good. Made in China. What can you do? But yeah, so you got to keep an eye out for stuff like that too. I mean, it happens unfortunately, and well, luckily that really won't hurt the performance of the amp, but it might allow some noise to get back into your electrical system. I don't know. It's a standard or a requirement that these companies do. Whether or not it helps or hurts anything on something like this, probably not, but everybody has to meet the compliance standards, so almost every piece of equipment you have is going to have some kind of filtering on there to prevent noise from getting back into the power lines. So we will fix that, and we will fix that wire that makes me unhappy. Well, this is kind of hard to solder. I don't want to take all the transformer wires out. So you got to kind of like hold it with one hand, feed the solder with the same hand, get a good joint, and not burn yourself all at the same time. I'm a big fan of fast-on connectors. Like, transformers do go bad. If this transformer goes bad, how do you replace it? You know, you got to unsolder all these lines. That's terrible. And all these connections are soldered into the power connector, so you can't get those out. Just not thought through, in my opinion. I don't know. It's not the way I would have done it. This board is marked with the caps, though. They have like the little notch on them. That was nice of them. At least on these two. The bigger ones may or may not be. It might be under that silicone stuff, but I'm going to leave that on there just because it's not going to cause any problems and it's flat enough as it is. I'm just going to bend the legs on this again. Not enough to be annoying, just enough to hold it in place. Make sure our caps look good. Fix our leg and solder them in there. Now, since these are taller, I will put some silicone in between them just to kind of give them a little support and keep them from vibrating around. I'll throw a blob in between here and then a blob to the dial bridge, and that'll keep them good and secure. They're not going to go anywhere. Let's fix this cap now. This is atrocious. I have my wrong solder sucker tip on there. Actually, I'm just going to take the whole thing out because this wire needs to get redone. Actually, the wire's not bad. It's not frayed. It's holding solder. It just has a really, really thick jacket on it. Alright. The filtering will do some filtering now. It's still frustrating to find something like that. Like, where the heck's the quality control at? And why aren't these lines... Like, whenever you do a wire to a board, push that wire into the board. Like, not crazy to where you're melting the insulation and pushing it through the board, but get it on the board. You know, like, it provides its own strain relief if you melt it into the board. There's really no reason to leave a wire floating off the board. So, I mean, that's what I'm going to do. I'm going to get it in there and push it into the board. And I know that's hard to see, but here, let's go in again. So you can see the blue one from the factory. The wires, like, I can stick my little stick in there. That means that any sort of vibrations or bending is going to be solely taken up by the wire in between the wire and the board. At least on here, there's a little something to kind of help it a little bit, you know. And then you can put a dab of silicone or something around there to really lock it into place. I mean, do you have to do that? No. Is it good practice? Yes. This wire is a little bit over insulated. It's probably 1000 volt. 600 volt. 600 volt wire on the secondary. Alright, no, actually that's on the primary. But still, I mean, who the heck's gonna power this with 600 volts? That's a little bit of overkill. Actually, you couldn't power it with 600 volts, but Alright, 4 more caps and this amp is done. These guys are kind of spread out a little bit. Helps if you can see what I'm doing there. This is another thing I'm not really a fan of, and I know it's going to be hard to see, but these are those caps that have those formed leads on them. They're pre-formed at the factory. I just don't understand why. It spaces the cap off the board and makes it more prone to vibrations. I'm sure there's a reason for it. Whether or not it's a good reason, I couldn't tell you. I don't use them though. You can buy them like that. I just get the regular ones, V the leads out, and solder them in. This one, the positive, is hard to decipher. But our goal is to have this thing come on, have no hum, and get some good sound out of it. I think we're going to be there. And I hope the owner will be happy. It's interesting that this actually uses a transform now that I think about it, because all the other SUNFIREs just use direct line voltage. I can't think of any of the other ones that use, like the amplifier circuit and probably the preamp are the same, but the power supplies are a little bit different up until this. I mean, it's a lower power amp, I guess. But you would think the transformer would be more expensive than the down converter or whatever they call it. Especially having 3 separate circuit boards in here with the transformer. I'm kind of curious why they went with a design like this. Unless this is... Well, I don't think it's that much older. Maybe it is, I don't know. I'm not really up with all the vintage timelines on the Carver stuff. That'll be another interesting thing to check out. Find out when this was made and then look at like a Super Junior or one of the other ones that uses a different type of supply and see if they're made like kind of around the same time. And interesting that in this power supply section, these caps are only rated for 85C. They're right next to, those are the 2 voltage regulators, so yeah, those get kind of warm. 47 and 16 volts. So we're putting 105C rated caps back in there. That should help a little bit. Still not as much as turning the power switch off. I'll say that 3 more times too before I end this stream. Turn your equipment off. Unless you're trying to upgrade. Like, if you're trying to upgrade, then leave it on. It's a good excuse for the wife. Oh, well, it's broken. Time to get a new one. That's the only time I approve of leaving your equipment plugged in 24/7 is if you're trying to force an upgrade that you normally wouldn't be allowed to buy. I can get on board with that one, but No other reason. Got to be careful with these boards too. Like you probably didn't hear it, but as I was heating that up, I had a little pop, and that means there's moisture in the board. Too much heat, and when you have moisture in the board, will force the pads to lift off the board. 470 and 16. I think I have some of those. Put our 220s away. These guys are a little bit bigger. Let's see if I have smaller ones in here. And I do not, so he's going to get the ones that are a little bigger. They should fit. A little snug, but it fits. The UPS caps are better. I'd rather do that than go to the smaller cam with the UVZ. Check the polarity. Double check. And actually having the larger cap in there will actually help reinforce some of these when I put a little silicone in there. So I'll just bend the regulators out of the way a little bit, make some room. Anytime I can, I prefer to use the UPS caps. They're just so much higher rated for life and temperature. Even with the best caps, though, I mean, they're gonna dry out with age. 20-25 years seems to be kind of the pushing the limits for an electrolytic cap. Ceramic caps, film caps, you know, typically those will last forever. These just aren't, I don't know, maybe the newer ones are like extended life and they will last a long time. Materials have improved over the years, as long as you get a quality cap. But I'm going to say still, yeah, I mean, in 20 years you're probably going to want to have any piece of equipment at least looked at. Alright, so this guy is recapped. We repaired the factory oops. Everything else looks good. We have the two mains to put in now. And I left those out just so I could have some room to get in here and work. Not blocking the whole board up on me. I will, I'm going to heat these wires up and push them in. Just because it's going to bother me if I don't do it. If I can. Remember, all this solder on here is lead free, so it's not rework friendly. Which other one's bad on there? Oh, that's hot. Those two aren't terrible. Well, we'll fix the two that were the worst right there on the top. Right by our bad cap. Alright, let's get the expensive monsters and put those in. And then start reassembly. I love the way they package these things too. When you buy them, they come in like a brick. Looks like the Colombian cartel dropped it off to me. Have to perform minor surgery just to get to them. I panicked there for a minute. I thought I ordered the wrong voltage. We're good. So 160 volts, 1000 microfarad, 160 volts, 1000 microfarad. 85C, 105C. And even though this is a smaller cap, like the same diameter, but it's a shorter cap, this one weighs more. It's a heavier cap, like junk. Total junk. And the LGU, what's the other series? That's a GU. I don't know, I use a lot of the L series. LGU, LGX, like, I don't know, these snap-in caps, they seem to function well. They function well for me. I like them. I'm a fan. They work good. Make sure your polarity's right on these big boys. Oh, we're going to run into a little problem here. The cap's just a little bit too wide in diameter. What is that, 470? 16 volt. Let's see if I can go to a smaller diameter. I might have to lean it over. I don't want to, but I might have to. I did not anticipate the large cap being in the way and ruining my day here. Let's see what I got in my little gift box. I planned ahead. I have the right diameter. So we'll pop those out and put the good ones back in. We'll pop the good ones out and put other good ones back in. Except now I have to cut the leads. Don't cut the leads flush if you're going to reuse the cap. Leave yourself a little working room. I'm glad I thought to order those. I didn't think I did, but same cap, two different series. One is a UPW, and UPW is the series you have to order to get the smaller diameter. The UPS would have been a slightly better cap, but it doesn't play nice with the rest of the components on the board, so UPW it is. And the UPW is still better than what was in there. You know, the ones that were in there were 85C. The ones going in there are 105C rated. And I think these are 3,000 hours and the other ones were 5,000, so you know. And that's a rating at temperature, how long the cap is expected to live, so I don't think anybody's going to be running their amp that hot, so it should not be an issue. Oh, here comes the dog. Oh, she's going to be mad. Hold on one second. Sorry about that. I had to clear off my dog's bed there. Just got a bed down in my little workshop area here. She likes to hang out and watch me work. And then as soon as I'm done, beg for food. It's kind of like the best life to live. Just hang out with somebody and then get free food. Alright, so we should be back in business, after we get these guys in here, again, check our polarities, make sure we're good. And you will run into that sometimes if you have spare parts. You know, if you're trying to just make things work with what you got, you know, you might run into a case where size, you know, does matter, and you have to either get creative or order some new caps. Now, if I really was in a bind, I could have mounted those caps on the bottom of the board. There's plenty of space here to do it. I don't like doing that unless I really have to. Like if it's a hot job and somebody's like really in a hurry and they need, you know, like this is gonna make or break their daughter's wedding or something, you know, I would do that. But generally, most of the stuff I do, nobody's in that much of a hurry to where I have to like do things the way I normally wouldn't. That fits a lot better. So these caps I'm going to actually solder with the solder sucker, just because it's a much hotter iron. And yeah, you guys can't really see that, can you? But these copper traces that are just covered in solder, I mean, they will suck the heat out of your iron really quick. So it pays to get in there with a higher powered iron just so you can get a good connection and a really good flow around those pins. And these are your main filter caps for the power supply, so you want to make sure that they have a good connection, and you don't want them to come loose either. So what I usually do is I'll get a bunch of solder on there and then I just kind of swirl it around. You don't want to get it too hot, and you don't need to have it like perfectly blobbed on there. Like there's enough solder on these traces to carry, you know, plenty of current. I'm not worried about, you know, how conductive they are. I'm just worried about making a good connection. Don't get it too hot though. You got to be, you know, be cautious of what I've said earlier. These boards do absorb moisture over time, and if you get it too hot, you might run into problems. And doing trace repairs on lifted traces is not fun on a board, especially on a board like this where they're routed. That one's actually pretty good. This buried one here is a little bit hard to get to. Sorry if I'm blowing on the microphone. I'm just trying to keep all the flux vapors from coming into my face. This one does not want to flow over. Definitely need good connections here though. Alright, that should do it for the power supply board. Do a little trimming, and then we can get on to rebuilding. Make sure you get a good set of nippers too. And try not to hold the leads by the tip, because I have shot one of them through my finger before and that hurts. Alright, power supply board. All these were zip tied together, so we'll find some fancy configuration that we like, and I'll throw some new zip ties in there. This board did use 2 different size screws. I don't know why. That's kind of ridiculous. was this one and this one. If not, we will find out in a minute. Let's turn off my irons. That's the big one. There's the small one. Yeah, not sure why they use two different screws on this. That one, that's kind of interesting. They're, I guess they are different brackets. One of them's just a tiny little L bracket. But still, not quite sure why they did that. Probably saved a penny per amplifier by not using a larger steel bracket. Some accountant got a promotion over that. Alright, don't strip out your screws. They don't need to be stupid tight, just dumb tight. Get my solder out of the way here. Alright, now we gotta put the amplifier board back in, and this is always fun because of the little insulator pads. So we need 4 insulator pads on there. There's 1, 2, 3, 4. Mica pads. I'm not really a fan of mica pads, but they do their job, I guess. I like silicone better. The devices that have plastic bottoms on them do not need any sort of insulating barrier electrically. They just need heat sinking capabilities, so you can just make sure you get some paste on there. I'm going to clean up a little bit of this paste, and in the process get any sort of garbage off the plate. Like there's some little shavings and crap on there. I'm going to get all that junk off. I don't know why there's... Well, it's probably from me soldering, actually. Little tiny blurbs. There was a shaving on there. I don't know what that's from. Maybe from a screw. I mean, it might not wreck your day, but it doesn't hurt to clean that up. Then the remaining paste, I'm just going to kind of spread out a little more evenly. And if you've watched any of my videos before, you know how much I hate thermal paste. There's no need to have thermal paste just scattered over this entire amp. Like, all this thermal paste up here above the devices does nothing. It's just waste and mess. And you know, it's only meant to be like a bridge between you know, the actual metal on the device and the metal on the plate. It's supposed to fill the voids. It's not supposed to actually like form a layer in between the two. You actually get less heat transfer when you do that. So all you need is one really tiny dot. I don't know if you can see that. That's it. That tiny little dot is all you need to get good thermal connection between the two devices. When it's smushed down, it'll spread out nice and flat. and you will have a happy amp. I am out of Q-tips, that sucks. Let's reuse this one. It's just I'm just getting some green blobs off there. But yeah, you just need a tiny little bit of thermal paste. If you're working on computer stuff, the same thing. You don't need a ton of thermal paste just blobbed into everything. Just a little bit. A little bit here, a little bit there. You'll be good to go. We have 2 more. Those 3 screws hold the FETs in. There should be 2 screws, one long one, one short one. The short one goes on the side that does not have the grounding wire. And when I reinstall this, I do it a little bit differently just because I don't like the way that they put a nut on top of it, because these standoffs are threaded here. The screws actually thread into the standoffs. And when you put a nut on there and then you tighten the crap out of a nut and you have a screw on there and you can't get to the nut to get it out real easy, you end up either stripping the nut or stripping the screw. And either one of those is not good. Actually, I believe that guy might go through. Oh, that goes there. The long one does go on this side. Getting the thermal pads lined up is kind of a process on these. So I like to just get the plate or the amp board kind of lightly installed. You can't see it, but I guess you don't really need to watch me putting a screw in. So I'm putting this in, but I'm not snugging it down. So I can still move the board around just a little bit. And the reason that I'm doing that is 2 of these devices in here, which are going to be hard to see, but the 2 larger FETs need to have the pads aligned with the holes going through them. And you want to make sure they're isolated, and you want to make sure that you get them tightened down pretty good to the plate. So if you leave the board loose a little bit, you can kind of wobble it around, and it makes getting your screws in there a little easier. If you tighten the board down, you're going to be fighting trying to align that screw up. And then you got to get washers and nuts and everything else on there, so try and make life a little easier for yourself. And sorry for the head in the shot, but I'm trying to align the mica insulator. There is no easy way to do this. It would have been nice if they, like these little nuts that have the little captive star washer on them. These are great. Some of the amps actually use these. They're phenomenal for holding devices down. These guys have lock washers and nuts and regular washers. There is nothing phenomenal about that. Except for trying to locate all the washers. And the screws are covered in thermal paste, which is going to get on my nerves. So the nuts too, like the lock washer is like glued into there. But I'll show you a little tip. If you have this green glue crap that's holding your fasteners down and you can't get it, sometimes you get lucky and you could chip it off, so we're going to try that first. And I got a chunk of it off, but not all of it. So that one played nice, but if you can't get it off, you have two choices. Choice number one is you can take a lighter or a blowtorch or something to it and burn it off. That works rather well. Or you can take your hot air station and heat it up to soldering temperature, and that'll kind of melt it, and then you can kind of pick it off with a pick or a pair of tweezers, or whatever you want to use. I got lucky on these ones. It kind of just flaked off. I do not re-glue them. I don't see the reason. You have a lock washer on there. The lock washer should be enough to keep them in place. But these are hard to get to, and they're a pain. You gotta have patience when you're trying to get these back on. And small fingers helps too, because you really gotta be able to get in there and get the screw started. This was one of the ones that had a captive washer on it, we would have been done already. So same thing, leave that a little bit loose. Get your nut started, leave it loose. So your board's still wobbling in there, and then you can go on to the next one. And I'm working from the farthest one to the closest one, just to try and make it as easy as possible on myself. See that one? Well, it didn't want to go through, but it ended up going in. And I did test all the FUTs, and I didn't show any shorts. There were no blown fuses on this board, so they should be good. I'm thinking that this just needed a good recap, and it's going to be up and running. But there is, oh geez, where'd that go? Right into the plate. There is the possibility that there is, a failed device somewhere on here. So keep that in, mind when you're doing this. You might have to take it all back apart and start over. Or not start over, but just, figure out where your problem is and go over from that. Two for two. Last one. And this one does not need an insulator. But I am missing the lock washer for it. And it may not have had one. I don't remember, or either that or I lost it. That does happen sometimes, but I have spares, so I don't care. Is it stuck to the glue? No, but this does have glue in it. Alright, so we have our main nuts for our bar. We have our insulating washer. These silver screws hold the little filter in for the speaker. Here's our washer for that. Here's our nut. Where's our lock washer at? There it is. Got it. Got it. It did have a washer. I just lost it temporarily. So we will pop our goo-filled screw in there. Actually, that's not the... Yes, it is. That is the washer for there. Just double checking. after this is done, we will be a little bit better off, but we still have to worry about all the insulators underneath the other pad. But we're on the home stretch. This screw is covered with glue on the tip. And I cannot get that screw started. I should be using my kickstand. Kickstand makes life a little bit easier, but I kind of need it on an angle to get in there. It's crazy that I have to work with tweezers to get a screw started. Couldn't have gave you like another inch in here to get anything in or out, or like I said, use there we go, it started. Yeah, that sucks. Alright, now the fun part. We have 2, 4, 6, 7 devices in there, and 4 of them need to be insulated. Now I can see the insulators for them, but you gotta pay attention to this part. This part is actually important, and you can see the insulator. You can't really see the device. You can see the device way down in there, but you got to make sure that you get this guy in straight and get him all the way down to the bottom of the device. Now, a lot of people will be tempted to bend the device up and off the plate. You don't want to do that, because then when you're moving the plate around trying to get the little clamp bracket to hold these things on, it's going to fall out of place. So this is where having a little bit of that thermal paste on the device helps. And I guess it just comes with experience. You just got to know where to position those pads so they're all the way to the bottom of the device and the device isn't shorted out. And you can kind of see it if you look down in there. And I can't really show it on camera just because the angle's going to suck anyways. But get them down in there and then push the devices down a little bit to get them to stick to the pad, because you remember we put a little dab of thermal paste on each one. But this part is critical. You do not want the FETs to short out. They can't touch one another, and they can't. Well, actually, the 2 pairs they can, but you don't want them to touch the plate, and you don't want them to short to one another. So just be careful when you're putting the pads in. This is another reason why I like the silicone ones, because you can see in there. And I could have changed them out for the silicone ones if I really wanted to, but I mean the mica ones work good if you have them installed properly. And you can feel the outline of the pads, so you know where they are. You can see it. So just make sure they're in there and make sure it's insulated. And yeah, you can check it. I'll show you how to check it to make sure you don't have any shorts. Because that would be bad. Because the first time you power it up, if you have a short on your power rails, you're going to, best case scenario, blow a fuse. Worst case scenario, you're going to blow the amp. Wow, this screw is bent and stripped. I'm surprised it's even taking the nut on there. It's This must have been loose, and yeah, you can see it. Let me zoom in. Oh, wrong way. Wrong button. Behave, camera. This screw must have been loose from the factory, and it must have been rattling in there. You can see there's like a shiny spot right in there. There's no threads there. The threads are gone. So, looks like another factory defect. There's no reason why those threads should be gone. No logical reason, anyways. The only explanation for that is a loose screw. And luckily it's below where the threads engage, so we're not going to have any problems. Connor Johnson, sorry I didn't see your comments up there. I wasn't paying attention. SPL Velodyne subwoofers. I have repaired some SPLs. I have I have 4 digital drives. I have 3 DD12 BGs and 1 DD10 BG that I have to work on. And then I will get into some SPL series. But if you keep tuning in, I will definitely get to some of those. I gotta get through my pile that I have in my other room over here. I gotta start getting that kind of cleaned out, because I am supposed to be renovating my basement, and it's kind of hard when I have subwoofers and amps and all kinds of other crap all over the place. So yeah, stay tuned. I will get to those. I can't promise you when, but it's on the list of things to do. Sub 10 going downhill. Yeah, I never really made a cap list for the sub 10. I have had a couple requests for it. I can put that on a to-do list too. And actually, the way I'll do it is I'll just make the list the next time I do a repair. That way everybody can kind of follow along, and then I'll just put it into either a spreadsheet or some sort of document that everybody can view. And I'm doing this the hard way with tweezers. Generally, you need a pair of forceps to get in here to get these screws started. But once you get them lightly started, you can get a finger on there and they kind of self-tighten because the star washers grab them. Alright, one more screw to start. And then we can tighten this guy down. We still have the grounding wire with the noise wire. I don't know why that's even on there. It makes no sense to me why they would use a bonding wire from the one board to the other on an aluminum plate when the whole aluminum plate acts as a grounding plate. But we have that and a couple more screws, and we can do a current limited test on this board. This nut is not going to behave. Alright, I'm going to break out the kickstand for this one. A common failure mode on the sub on the so the problem with the Velodynes is when the caps go bad, they cause other things to go bad on the board, and usually it involves some damage. On the DD series, when they go bad, they actually burn through the traces on the board, so it requires a ton of rework. If you're lucky, you know, it's just a couple of pads to fix. If you're unlucky, you got to do a lot of trace work. And I have both failures to work through. And they're surface mount parts too, which kind of sucks. So there's really no easy way to get them off once they're corroded. But yeah, I plan to go over a couple of those. I don't know why it looks like my stream froze. Hopefully that comes back. It says I have excellent connection, but I don't see anything live. If anybody is watching right now still currently, let me know if you can see what I'm doing or if my stream actually froze. Let's try this. Let's go. Oh, we're back. All right. Nope. No, we're not. All right. Yeah, all right. I must have clicked on something. I was watching it in the past. I don't know what the heck I did. That was weird. I was watching what I already did while I was live streaming. Haven't experienced that before. But these screws are a pain to get to, these nuts, I mean. Forceps are the best way to do it. Needle nose pliers will get you there, but you're going to fight them. A nut driver would probably be the best, which I have, but I don't really feel like going upstairs to get. Alright, we're going to lock the center one down first. These don't have to be stupid tight, but you want them to be snug. The star washers do a fairly good job of keeping them from coming loose. This one all the way in the back is the challenge. Alright. We are locked down. Alright, yeah, good the stream didn't cut out. Something weird happened on my screen over here. It just like kind of paused and then like rewound itself. I might have clicked on it on accident because the mouse is like literally right next to me. Alright, board is in. We're going to do a quick check for shorts. And let's get a little light. Yeah, this is going to be hard to see. I'll use my little poker here. So you can see all the T0220 devices down here on the bottom. All 7 of them. And we're going to check the center to center on the MOSFETs that could possibly be touching the plate. So we're going to go center to center and center to plate on all of them just to make sure we don't have any shorts. If you don't have any shorts, that means your insulators are in good. If you do have shorts, then you got to loosen all them screws back up, readjust the thermal pads, and start over. So here we go. So we're conductive on the plate. Now let's go to our first device. So our 2 devices are electrically connected together. That's good. No, and we're checking the center leg. We're not going to the plate. So now we'll go to the other ones. We're not shorted in between the devices. And now we'll go from those 2 are connected, but not to the plate. We're good. No shorts. No shorts. And it's more of a sanity check than anything. You don't really have to do it, but I don't want to take this thing apart. It's already been apart. I want this thing to turn on and make a nice clean sine wave that I can show everybody. These things are kind of heavy for what they are. I know that it's the transformer. Alright, let's get this guy back in. Now, the coil on here goes inside the gap. If you're working on this, remember that. That is the only way that this guy will fit inside of the box. I don't know why they have essentially a common mode filter on the output of the sub, but for some reason they needed it. Some kind of noise, or I don't know why it's there. My knowledge is limited to that. If somebody knows why that's there, let me know. Like one of you electrical guys or electronics guys. And I know that sounds weird, but it's circuit theory, and I don't understand all that stuff yet. I just know how to make these things work and find the problems. And I know the basics. I don't know why you would put a filter on the output of a subwoofer. I've never seen it before except for on this amp. And it's not for like a crossover frequency or anything like that. It's a common mode filter. So I know what it is, I just don't know what it does. And it seems kind of counterintuitive to filter out noise when you're trying to generate noise. Maybe it's just a specific frequency that it's blocking, I don't know. Alright, now we have this little guy, our little bonding wire that links our two boards together. I like to put that on first because it fits really nicely over the little dimple that the screw threads through. Then I like to take the washer on top of that, the lock washer. Actually, pause for a second. I like to put a regular washer over that, and then the lock washer. I feel when you do it that way, you get a far better connection. And it makes it easier to take apart. I'm just using a lock washer because that's what I have. But the combination of the lock washer and the star washer and a regular washer should make sure that you don't have any problems there. And it'll be easy to get off. That's the most important part. Make it easier for the next guy if there is a next guy and he has to do any of this stuff. And it's not a critical connection point. It's just a pain of a connection point. Again, probably a place where a nut driver would come in handy. I don't know if I have any this small, to be honest. I'd probably have to go get a socket, and maybe it's time I invest in a small little nut driver set. Alright, so we can tighten these up now. Again, not too tight, just snug. Everything else on the board is snug, so these guys can be snugged down. And then when you tighten this nut with the lock washer down, it locks the screw in place. So if you're trying to take this apart and you don't take that nut off, you're going to break the screw. And I learned that the hard way the first time I worked on one of these. Then you got to hope you can get it out or drill it out, and I don't know. It's a lot of extra work for really nothing. So make sure you take it apart the right way, and if you want to be nice, put a washer on there and reinstall it like I did so that it's easy to take apart for the next guy. Paying it forward with amp repairs if that's a thing. This is not the right. It doesn't have to be crazy tight, just tight enough to get a good ground connection in there. I'm happy with that. Alright, what is left? We have our speaker outputs, we have our input connected, we have our input to the amp board connected, zip ties, and the fancy little rainbow cable. And it was nice of them to at least make this so that it was backwards compatible. Doesn't matter which way you put it in, I don't think. Purple, blue, green, yellow, orange, red, black, brown. No, it does not matter. Purple goes to there, or purple goes to there. So at least somebody was thinking, so you can't really screw that up. Alright, I don't think there is anything left but to power on and see what happens. Luckily this has a massive transfer. Make sure your outputs are not shorted. Don't power on with your outputs shorted out. That's another way to have a bad day. Let's zoom out a little bit. Come on, camera, be nice to me. Coffee break. I still need to work on my artificial speaker coffee warmer. I want to make a 300 watt dummy speaker that I can sip my coffee on, and when I'm testing my amps it'll heat my coffee up. I'm going to do it, it's just a matter of when. So we're going to turn volume all the way down. We're going to turn the frequency to bypass, phase to 0. Phase doesn't really matter. We will check the fuse. Fuse is probably good, but I'm going to check it anyways. And of course it's one of the ones that are a nightmare to get out. I'm actually going to make sure that it has the right fuse in it too. That's another thing I find, people never put the right fuse back in stuff. So this is a for 120 volts, it wants a 4 amp. And it is a 4 amp, so this one's good. This one has not been tampered with. A lot of these you can run at 220. I recommend doing it if you have the ability to wire up the power to 220. They are a little more efficient at 220. They're not louder or anything like that, but you can run them at 220. Alright, make sure our powers are off. We are good. Amp has the switch on. And I think you guys can see the little LED up here. Let's see what happens. We're going to go current limited first. Make sure our outputs are not shorted. And here we go. We have dim. Dim light is good. Amp is in standby. Alright, I'm going to shut it down. My wife was sleeping in the living room. I don't know if she still is or not. But we're going to do a speaker test. We're going to find out real quick if she is. We'll be grounded tomorrow. I want to hear this thing though. Since it was a two-part and we put some time into it, I want to hear the output. So we'll hook it into my little makeshift jumper harness. We're going to make sure that these don't short and that they're not touching anything metal that they shouldn't be. And we're going to go current limited. I'm giving it 33 hertz right now. I heard the speaker come on. Let's see. Oh yeah, we got volume. I'm not going to crank it up because I will have an unhappy wife if I crank it up, but I don't hear any distortion. I'll show you guys in the scope when I feed it into the dummy load. Yeah, it's a nice clean sound. Good. Alright, let's power down. And I modified my my dummy load, and I added some wires to it so I can hook it directly up to the scope. And I still don't have a good way to show you guys my good scope. That's going to be a chore for a different day. But I do have my little Quamat or Quimat or whatever the hell you call this thing. So we're going to watch it on here. And this goes through the dummy load. So we're going to be giving it 4 ohms, which is, I believe, a little bit higher than this guy. I think that this guy uses an 8 ohm driver, but we're going to give it 4 ohms, which won't hurt it as long as we're not running it for extended periods of time at really high levels. And I now have a BNC that comes directly out of my dummy load, so I can just plug it in and go right to my scope. Let's kill some of the lights so we can see it a little better. I don't know if that helped or made it worse. I think that made it worse. Well, we're going to zoom in anyways. So, yeah, scope is on. We're at 5 volts. Well, let's see where we end up at 5 volts. I'm going to go current limited. Volume's all the way down. And we're feeding into our 300 watt dummy load there. And we hit current limit right away. I don't know if you guys saw that flash. The amp, my bulb is fully glowing and it's resetting the power supply. So let's go full power. Make this guy happy. It needs more than an amp to run. Now we're going to slowly crank the volume up. There it is. We can check our phase on there. And this isn't going to show it up very well, but I can see it here moving a little bit. But we can go take our frequency up. We're at 33 hertz right now, and I'm showing 34.3 for a $20 device or however much this was. I'm going to say that's good enough. Let's crank it up. Let's go to 50 hertz. Let's go to 60 hertz. Let's go to 100 hertz. There's 100 hertz right there. And it's showing we need a little more gain. And I'm going to move the waveform down. Spread it out a little bit so we can get a good look at it. That's a clean waveform. I mean, there's a tiny little bit of distortion down on the bottom dip there, but I'll check it on the good scope. But I mean, it's clean. It's clean enough for what I would be or what I would call good. And you know, zoomed in so I get a good sample. I'm showing 100.1 hertz. The waveform looks good. I'm getting plenty of volume. My dummy load's getting warm. I'm only at about maybe 10% volume. This thing's got plenty of room. We're at 26 volts output right now. We're putting some juice out. Now, granted, I am feeding it into a resistive load too, so the waveform will look a little bit different than if it was going into a speaker. It looks a little weird on the bottom, so I'll verify that on the scope. And I'll also check it with the speaker. I can't do that tonight though, because I'm going to have to turn the volume up on the speaker fairly loud to get a good measurement on it. But either way, it's putting out power. It sounded clean when I was running it through the sub. And I'm actually going to do it at a lower volume at 100 hertz just because I want to hear it. So we're going to shut that down. I'm going to... Yeah, I can't go with this output into the scope. I got to go to a different one because I don't want to go through the speaker. But if there is distortion, I should be able to hear it at 100 hertz at a lower volume. So I'm going to listen to it. You guys probably will not be able to hear it. It will be a very slight power supply distortion. I don't know. You guys might be able to hear it, but I'm listening for any sort of irregularities, and I'm going to sweep the frequency down. So I'm down to 30 hertz right now, and I did a sweep from 100 to 30, and it sounds really nice and clean. So I am gonna, well here, I can't let you hear it, because I can't crank it up, but I can show it to you. This is my test woofer. I hang it from the ceiling. It's a Logitech out of a Z5500. They're actually, it's made by Tangband. It's a good woofer just for testing, you know, just smaller low power repairs. You can't hear it, but it's clean. You can see it. It's going. The camera captures it kind of cool. Let's see how low we can go. We're at 18 hertz. 17, 16, 15. The camera's not picking up the movement. It's moving. This amp will do 10 hertz. Pretty good for a SUNFIRE, so we have a successful repair. I will I'll go over it tomorrow and you know, just verify everything, make sure that everything's within spec, you know, check the output waveform, make sure there's no distortion in there, make sure everything's clean, and then I'll put it through a stress test, crank it up about 50%, let it get good and hot, make sure that nothing fails. But I think we have a successful repair on an HRS 12. This was kind of an easy one, if you could call that easy, but there really was nothing blowing on it. I believe it just needed a recap. I'll take it though, you know, like I'd rather have a easier repair every once in a while compared to, you know, something like this that we're going to get into that's going to be a lot more difficult. So what time? Yeah, it's 1:44. I think we're going to call it a night tonight. I'm not going to get into anything else, but I appreciate you guys tuning in. I will try and get these videos put together so it's one instead of being in two parts, so it's a little bit easier to follow. And let's see if there's any other questions. Yeah, Connor, thanks for tuning in, man. I'll try and get some of that info out to you as soon as I can. Maybe I'll squeeze in a sub 10 tomorrow. I know I have two that need to go. I'll have to look through my list and see who's up next and what I have to do, but I'll try and get some of that stuff scheduled in at least for this week, because I got to get moving on these things. I really have to stop messing around and get some of these repairs done. So thank you guys for tuning in. Remember to like and subscribe, and I will see you as soon as I can, and we'll get to another repair. Have a good night.